Yes, so today I will discuss how you can secure your IPFS website, and so focusing on kind of like interaction between IPFS and HTTP. Quick presentation for myself before. So I'm a research engineer at Cloudflare, working on like this distributed web project, so IPFS, Ethereum, along with like other research projects. Tend to like croissant, which might sound cliche, but like they come a lot in this presentation, so you should just know. There are no croissants in Lisbon, sadly. At least like there are brioche croissants, but no like French croissant, and like they are known like offered in here today. So well, for next time, I think. So just quick introduction for like what IPFS is. I think you all know, but like let's just see a bit more how like these interact from like a request pattern. So imagine you're like, I don't know, in Paris, and so you're just like sitting at a terrace, you like come and say, hey, like, bonjour, like I would like a croissant. And yeah, usually the waiter will come back and say, hey, like you have a croissant. And you really need to make sure, usually in places you go, like that you have the right croissant. And so it's like kind of similar to IPFS, you request a CID and like you just check that like the content you have matches the CID. Because otherwise, you might end up with something that looks like a croissant, but it's not really the thing you were expecting. And yeah, so that's kind of like why we have IPFS, just to make sure that you have the croissant you expect. And so just to give you like a full plan of like what we're going to discuss is like we're going to start quickly with like a presentation of like IPFS with like slightly more technical diagrams. Then how you can serve the content that you have on IPFS. We then go through how you can secure a request for that content. Then if you want to host a node, how like is a possible way to try to secure that node rather easily. And then we briefly touch on like naming resources. So first, IPFS and content verification. On the web, when you want to make a request, so like you're the eyeball in your web browser, and so you will request https example.com. The first thing you need to have is the IP address for example.com because, well, there's nothing to be reached for example.com. So we use a DNS resolver that like will return you an IP address, such as like 1234. And once you have that IP address, you will make an HTTP request to the IP address saying that you're looking for example.com, and it will return you the content, and yeah, that's fine. You have your you have your homepage, and everything's good. On IPFS, it works slightly differently, but in a way, it's similar. So instead of like your web browser, you have your IPFS node, and when you request content by CID to the IPFS node, it's very similar to like example.com. You don't know where to look for the content. The first thing you will do is to resolve the content to a provider that will be able to have it. So like you can query the DHT, which would say, hey, for CID 1234, you should reach out to like this peer or this IP address. And then you request the content from like this peer, this IP address. And because the way CIDs are constructed, you're also able, as you're receiving the content, to validate that that was the content you were expecting. And yeah, that's it. You have now like an IPFS request. So how do you serve content? And I really focus on HTTP because like at Cloudflare, that's like the most use we've seen for IPFS. And really, I think as it's been touched on by like the previous speakers, it's mostly about like interoperability. Like there's no magic storage, nothing happened. Like you can like use like one gateway. So an IPFS gateway, as like most of you should know, and like I will like just briefly touch on that, is an HTTP interface to the IPFS network. So that means using the HTTP protocol, you will be able to access content that is like on a totally different network, and like this case, IPFS. A gateway, so in our case like Cloudflare, will like leverage like an HTTP cache, which is like standard web technology, to make content and retrieval faster. Finally, to retrieve content, Cloudflare is also running and operating a set of IPFS nodes, so it can talk IPFS language, and it makes the interface between HTTP and IPFS. If you want to create an IPFS gateway, and I won't do that as a live demo because, I don't know, wireless sometimes breaks, like as pictures. For Cloudflare, how that would work, you would go on our website, you would go like register like your domain name, etc. And then you like end up on the Web3 tab, and you just want to create a gateway. In our case, we're going to create like the IPFS camp gateway, but for Crasser.world. So IPFS camp.crasser.world. We just can add like a small description, so it's like croissant for you all, and I'm sorry I don't have croissant. There are only brioche croissant in Portugal. This is a DNS link gateway. I won't touch on like what DNS link is, but in short, it's a way to associate a DNS domain to a CID, which is an IPFS content. And because we said we want a DNS link gateway, we're also pointing it to some content that is on IPFS. And so in this case, it's the like complex line you see at the end, /IPFS/BAFI something. And that's it. If you were to go to like ipfscamp.croissant.world in your web browser, you would see this croissant picture. And so from IPFS, from HTTP, that's it. The question is, that's good. You have like the picture, etc. Is it secure? Is it private? Like, what's the difficulty? And like as like the few talks before have touched on, it might be a bit more complex than just setting up a gateway and like leave it be. So how do you secure your request? And mainly, I want to like say that like we're going to piggyback a lot on the existing web infrastructure, because like HTTP has to deal with like these problems for like a long time, and so ideally we don't reinvent the wheel. We leverage the tools that exist already to like make sure our content is still secure. So in terms of like brief introduction to like standard web security and like the 3 points we mentioned here, the first thing we want for a domain name is an X509 certificate, also referred to as an SSL certificate, which is a dead protocol for some time. But the idea is like you have a domain name, and so your web browser should be able to authenticate that domain name when it receives it, so that there's no phishing attempt. So that's one of the things an IPFS gateway is providing, so that like from the web browser, you're able to like identify the source of the request. Then a second point that like we really want to have is to have some coarse rules, and these can be specified at the gateway level. The idea is like when you're serving the croissant, you can like serve it to the whole world, but do you want the croissant to be accessed from another website? Do you want the croissant to be accessed from like another host with like some special rules on caching, on iframes, and etc.? And so all these rules can be specified via HTTP. Finally, IPFS provides like immutable content, which is great because like you can just access a CID, you can cache it, and you can like validate it. The thing is, sometimes you don't really know if the CID is there. You might want to like do some redirection if you like having like a website or folders. And so one thing which is interesting now, like on IPFS, is you can use like custom redirect pages. So if you have a website and you have like sometimes some pages that like will not be accessed, you can like just set up a custom redirect. So like you have a custom for page, or you have like you redirect people to your home page and etc. And so it's kind of a way to keep like the immutability of the CID and benefit from like having like kind of like mutability and like dynamic content be served on IPFS. The main question is like, why do we want to leverage HTTP to serve IPFS? There's definitely like kind of like this interaction between the two content can be tricky, but one of the main benefit of using HTTP is there's a lot of tooling. Like if you're using like a normal HTTP and like edge network, you like can have rate limiting, like it's just built in. You can also benefit from like custom response header, so you can have, I don't know, like pass some more information through headers. You can pass some coarse rules. You can have like some access control, and all that is built in the HTTP tooling. In addition, of course, because you're using like a normal HTTP cache and like, I don't know, like a glorified Nginx, you can set up your own cache rules, and so you will control how often people should cache content in their browser, how often the content should be, like for how long the content should be cached at the CDN level, etc. Finally, you also benefit from like image resizings, for instance, which may be like very beneficial for your content as it's accessed through IPFS. If you want, I don't know, to make a thumbnail, or if you want to like just make sure that like the content which is static on IPFS has some slightly extra features. Of course, with the HTTP tooling, you can like also benefit from having A/B testing, like all the redirect, analytics, etc. I won't touch on like all of that, but basically you can think of, if you use HTTP, it comes already with a lot of tooling. I just want to mention something quick as a non-honorable mention, because I do think one of the things you lose when you use HTTP for IPFS is you don't have natively the validation of the CID, because HTTP relies mainly for like HTTPS on X509, but you don't have like the integrity of the content. And so interestingly on the web, you have something which is called sub-resource integrity. So that means like when you have an HTML page, you can link to all the sub-content that, and like provide the hash so that you know the sub-content that you have would actually be the one that you expect. And so IPFS could work similarly. So like sub-resource integrity, the good thing is like that built-in browser, there's like 3 hashes algorithms that you can have, but not fully compatible with IPFS. For various reasons, and the main reason is like the sub-resource integrity is just a hash over the full content and like doesn't support like DAG building, Merkle trees, and like just various features that IPFS might have. As a quick example, if you have a row node, you can actually convert an IPFS CID into like a sub-resource integrity compatible hash. And so this is a command that we would use. It's just a brief mention, because like for now it's not practical, but definitely I think as the content IPFS gets more weight and gets integrated in browsers, maybe like more standard, that's some things that you could expect to be like some kind of a bridge between like the existing web and like the web we could have in the future. Finally, I've talked a lot about gateways. The thing is, I didn't say how you can provide content to the network. And so kind of the usual or historical way to do that is you run your own node, you have content on your side, and you expose it to the IPFS network. Once again, there's no magic, so how can that work? And I will really mention, once again, using the HTTP tooling. So you might notice it's very similar to a gateway pattern and gateway diagram, because you can expose your nodes to the swarm via like a protocol built on top of HTTP, which is like WebSocket. And the good thing is like, instead of like, when you will ask people to connect to your node, you will say, hey, you can connect to like my address, to my domain, and this will all pass through HTTP. The good thing is you benefit from like all the toolings we've seen before. Like you have like caching, you can have access control, and the great thing is like you're the one providing the IPFS content through HTTP. So in a way, you just have like the good of both worlds. Like you benefit from like all the tooling that already exists for and has been built to build the web we know today, and you can just extend it with the benefits of IPFS. Once again, a small demo. Due to like various like lacking in internet, I would just like go through the slides to explain what the demo could have been if it was live. So if you want to start an IPFS node that like is exposed through WebSocket, how do you do that? So first of all, you download Kubo, your favorite implementation of IPFS. You do IPFS init just to like have a private key, etc. And then you need to tune slightly the configuration to say that like the transport you would be using to expose your node is WebSocket. So like I just say, hey, like for the swarm, I would use like the WebSocket transport, and this is the address I would be using. So you notice the address is like IP4 and IP6, just like the broadcast address, just so when a request will come via WebSocket to our node, if it has like a domain name, etc., we're still able to serve it, and that just allows us to have a forward proxy. And finally, now that you have the configuration, you just launch the daemon, and voila. You may want to expose it to like an edge network, and so in our case, I will expose it to Cloudflare, but like there are also tunneling service you could use. And so I would use like Cloudflare tunnel. I will like say the URL is like HTTP and the local host and like the local port for WebSocket, and then I have like a dedicated tunnel, so that's specific to Cloudflare, but I have a dedicated tunnel to say, hey, like when I receive a request for like IPFS camp Croissant World, it should pass by my node. And that's it, you can add content. A funny thing, you can also advertise if you have like still using DNS, you can say, hey, so like your PID would be /DNS/node.ipfscamp.croissant.world and the WebSocket, and that's it. You're just using HTTP tooling to serve IPFS content. The main question is, why would we want such a particular setup and not just do IPFS init, IPFS daemon, and that's it? One of the reasons, it integrates directly with browsers. So IPFS interaction with browsers is still, still has a way to go, but definitely that's one of the way you could do that. It's like you expose your node directly to the web browsers because you're speaking HTTP, you're speaking like WebSockets, and so that's protocols which already exist. You also benefit from having like an X509 certificate, so like you don't have to worry about the web PKI in this setup. As I mentioned, it's built on top of HTTP, so you benefit from like all the toolings that you have, access control, rate limiting, and etc., and analytics. And finally, in terms of like networking from your node perspective, is very simple because like you would open a tunnel to an edge network, so you only have like one egress rule to open like on a firewall. You would like just reach out to this edge network, and that's it. You have like no ingress rule to like worry about, no other egress pattern. So like from like network perspective, it's just easier. I want also to touch on another topic, which is like naming. And so like through all this presentation, I've used croissant.world. So already .world is a weird TLD, but that's how the DNS work. And yeah, I've used for like all the node, the providing, the gateway, always using croissant.world. And it's like one name to serve them all. It's like just like DNS name. But the main question at like IPFS camp and like more like in a decentralized spirit, why couldn't I choose like, I don't know, IPNS or like something different? So I just make a small comparison table in terms of like what DNS provides and what IPNS provides. And so they are very similar in terms of like what they provide, making slightly different choices at like various levels. So in terms of the IPNS name is just a hash over public key. Let's put it like this, even though it's slightly more complicated. And that leads to names which are harder to parse. While the DNS name is just labels which have been standardized at the IETF, which are more easily human readable, even though studies have shown that like it could also be hard to parse. The main thing I think that like IPNS gets right is like all over like the records are always signed like with like a private key of the user, and so like because the name is directly the public key, you just know that the records that you're receiving are actually the record that like was signed by the one owning the domain. And DNS has something like that. It's called DNSSEC. And the good thing with DNSSEC, it does something very similar. You can have like delegation over like various labels. You also have signatures, and so you're also able to authenticate the owner of a certain domain. The transport for like IPNS, DNS are different. IPNS like leverages technology that like the IPFS ecosystem has been leveraging, so like DHT and PubSub. DNS is over like UDP, TCP, HTTP, obvious HTTP if you want some more privacy. The trust anchor is different. There's no real trust anchor for like IPNS because you're just like verifying that like the record that you're getting has a signature which matches the name of the domain, while for DNS, usually you would leverage like IANA signatures. And so you have like IANA and then the trust falls down from there. In terms of standardization, I'm glad to have modified this slide yesterday because there's now a spec for IPNS, so you can like go on GitHub and read it. For DNS, it's been standardized over like many RFCs at the IETF. Finally, in terms of integrations for now, like IPNS is more targeted like the IPFS ecosystem, and DNS is just everywhere. So you could use one or the other. Just for like internet and like convenient of use. In all these like presentation, I've leveraged DNS. And that's it. So finally, what do we learn? What did we learn? Sending IPFS is definitely like an evolution over HTTP in terms of like content providing, but like HTTP provides a lot of tooling that you can already leverage to like still better serve your IPFS content. Names are hard, and this is like at like various levels, and making things like human readable for IPFS may require some work to like keep the trust, keep like the decentralized spirit of the network, but there are tools that like in movement that are going like us through there. And finally, one thing I would really like is like just browser integration of IPFS. It's being like built step by step. And definitely I think there's like movement being done on both the browser side and IPFS side to make that happen. And that's it. Thank you.